just a lot of fun. All right, it is 2 hours UTC, and it's time once again for Astronomy Daily Live. So hope everybody's doing well out there. Everything's good here. It's going to be cold here tonight. Cold, very, very cold storm is blowing through, and it's gonna be cold. It's gonna be very, very cold here. And that is probably going to blow through. It's probably going to blow through the rest of the country. So expect some weird weather, to all of you east of me here. So, Otto, what have you got there? Hey.
Just showing the group my Star Trek sign. I couldn't resist. To boldly go, yeah.
Raise it up a little bit.
Whoa.
Up. As in up.
Up. Up more.
Here we go. Now to your, I think it's going to be to your right. Nope, the other way.
The other right. Okay.
The other right. There we go. There, we can more or less see.
The trouble is, I don't get real-time video for what I'm doing. There's a lag on it.
Yeah.
Wow.
It's all right. It's all right. You got it.
Idea. You boldly go.
Boldly go.
I just thought that was so funny.
Very awesome. And Bobby, hey, what's going on over there?
Oh.
I hear noises.
Not that much. I'm having a little bit of trouble because I'm having a little bit of trouble.
Okay. Well, take care of it. I know you will. So, howdy to Carolina Sky Astronomy. Hey.
All right. Check 1 2. Check 1 2. Check 1 2.
So, Carolina Sky Astronomy. Yeah, you're.
Check 1 2. Check 1 2. Check 1 2.
Okay, now we're getting like serious echo from somebody.
Check 1 2. Check 1 2. Check 1 2.
I don't think that's me. Now we're getting like serious echo from somebody. No, that's not me. That's me. Now we're getting like serious echo.
I didn't change anything.
I'm going to try to mute.
Did that stop it?
Okay, so I just muted Bobby and it went away.
Now I hear nothing.
Do you hear me? Do you hear me? No?
God.
Do you hear me at all?
This is a trip, this is.
Atta, you can hear me or no?
I do now. I do now.
Oh,
there we go.
That helps.
Yeah,
that helps. All right, and I think Bobby's back.
And I don't know what's happening here. I mean, I'm trying to do on.
Yeah.
Hold on.
Oh, he's running off again.
I didn't change anything myself.
Yeah, no, I think Bobby's always very, very busy with his computer things, so it looks like it's constantly changing, and he hasn't quite stabilized the situation there. So here he comes. He's coming back. He's gonna get back on. Right, so,
hey, I mean, I'm doing every day for my mentality. Dang it.
Well, hang in there. Just gotta hang by a thread. That's all we need. So, all right. Well, cool. So, do you think you're in a stable place there, Bobby? Can I?
Yeah.
Okay. Good. Excellent. I wanted to say howdy to the rest of the chatters. I noticed that Tom was there.
I'm going to log completely off and log on again and see what
Okay.
happens.
All right. You've got some troubles too?
Yeah.
Wow. Okay.
Completely off and log on again and see what
Okay.
happens.
All right. You've got some troubles too?
Oh, yeah, I hear lots of echoes.
Oh, okay.
Log on again and see what
All right. Yep. So there goes Atta. Who knows? We had a little warpage in the Hangouts tonight. So that's that kind of thing happens. So hi to Carolina Sky Astronomy. Hi to Tom. Hi to Uncle Bill. 9-inch colas. Hey, nice to see you back here. Glad you could stop in for as long as you want. All's well. All's well here. It's going to be cold, an unusual cold, but otherwise doing really, really great. All right, good. I think we are caught up. Hey, I wanted to.
And there's Deep Sky Dew.
Deep Sky Dude is here. Oh, very cool. Very nice. Hey, nice to see you, Deep Sky Dude. So, yeah, let's grab our favorite consumables of choice, whatever that might be. And the sun here is just beginning to set. Cheers. All right. Excellent. Yeah, so everything's good here. But yeah, hey, I wanted to draw your attention to the sun right now. Let's go over to Soho, and let's look at those two wide field LASCO images. Both images are showing something a little interesting. Okay, so here comes Atta back. Are you back, Atta? Are you there?
Yes.
You are. You hear any echoing?
Yeah, more or less, I guess. I'm
Okay.
here. Hello.
There's a little bit of a delay. Yeah, I think there's a little bit of a delay.
Yeah, there's a delay factor.
Yeah. Huh. And that makes being on the panel difficult.
What is that? What causes that?
I don't know. Are you
Probably Hangouts being transgressive.
Are you I mean, I send you a link, right? And that like opens up a window of some sort. But are you watching this on YouTube right now, or are you watching it on the
I'm watching on YouTube.
Okay. That might be why there's a delay. Yeah, I don't know. I don't know. It's possible too, that they're playing with the code and trying things, and yeah, this is just a weird thing. So, all right, well, she popped back out. So anyway, let's go over to Soho and check out.
Jim, I think that's the problem. The problem is because Alta doesn't have the Spock ears on.
Well, you know what? I thought of that myself, and I think you're exactly right, Jim. And yeah, Tom actually said exactly what I was talking about, much better. So there is some kind of hangout window, as opposed to watching this on YouTube as a panelist. I think as as a panelist, you get onto some kind of hangout window where we have a live conversation between myself and the panelists, but there's a little bit of a delay. There's about I don't know, it's probably maybe a 10 or 20-second delay.
10 to 30.
I don't know. There's no delay where I am. I just clicked on your Hangouts thingy.
Okay, good.
And got right in here. But what I can't get in this window, or don't know how to get it, is the chat. I would love to see the chat because I key in comments.
What you need to do there is you can do what I do, and that is I go to the YouTube live stream, and where the chat is in the upper right.
Okay, I get it, and I do the
pop out.
Yeah. And then I come back to this screen, right?
And get rid of the YouTube
and I have
screen altogether.
Yeah, right. I got it. I'll just work on that while you go ahead.
Yeah.
Go right ahead. I know what you're talking about.
Good. Excellent. All right. So yeah, let's look at the sun here. I'm gonna share my screen. Share the screen. We'll come over here to Soho, and this is as it says, the very latest Soho images. So if we look at the wide field one, which is this LASCO C3, and I forget exactly what LASCO stands for. It's a coronagraph, so we can look at it here. It's just a device that they sort of stick in the field. You have to block out most of the light of the sun, and then you can kind of see the structure around it.
Large angle and spectrometric chronograph.
Cool. What is it? Large angle and spectrometric chronograph. Cool. LASCO. Excellent. Thank you, Page Master. But so yeah. But the cool thing is that we've got the Pleiades right in the field of view, and in fact, pretty much, right in conjunction with the sun at this point. So that was 0054. So that was about an hour and a half ago or so. So yeah, as of pretty much right now. The Pleiades are directly behind the sun. So, of course, that places the sun in the constellation Taurus. So, if you're a Taurus, you were born somewhere around this time. But yeah, there's the Pleiades. The Hyades are trying to. I want to say that the Hyades are down here, but yeah, I'm not quite sure. I think we should be able to see the Hyades too. So yeah, pretty nice. So can I zoom out a little bit there? See the whole thing. So yeah, I mean, you can really see that. You can see some pretty faint stars. Those of you who are familiar with the Pleiades, you're seeing some pretty faint stars there, 4th, 5th magnitude. So pretty good, I would say. So there's one neat thing, but then. Even closer in, which is this other one. Oh, we should make a movie out of it. Let's do that. These are always kind of fun to watch. Okay, so it's actually showing up here too. So here is Mercury. And Mercury is, as you can see, in retrograde motion. It's moving this way. The rest of the sky is moving left to right. This is moving right to left. It's actually orbiting the sun, of course, and it is coming around this way, and it's actually going to be going between us and the sun. It's not going to transit the sun, but it's going to come really, really close. We're actually going to have a transit of the sun by Mercury. I think that happens in November. And I think we'll be able to see it here in North America. I forget exactly where else. But as you can see, it sort of disappears behind that disk. And that's actually where the red portion of this thing takes over. So here's the whole, 4 or 5 days of time. You can sort of see the background sky. You can see the Pleiades here slowly moving east to west over the course of many, many days. And Mercury coming in like that too. See these weird lines here? That's just caused by overexposure. So it's just, Mercury is so bright, it was just causing what's called bleeding. It's just a common CCD thing. When there's too much light, the buckets get too full and they spill over. So that's what that is. All right, so there's that. But then we can go to the C2, and we can actually see a little bit more of Mercury and what it's doing. So again, this was about an hour and a half ago or so now. But there is Mercury, and it's really, it's kind of interesting how optically distorted these objects get as they get closer to the coronagraph. The coronagraph really, really, really messes with the optics a lot. And even way out here, you can definitely see that Mercury isn't a spot. It's some kind of weird distorted diffraction thing. So that's pretty cool. But yeah, that's just how it is. That's why pretty much everything in this big red circle is really useless information because of all the diffraction.
Hey, Kira H.
Hey there, Kira H. Nice to see you.
Jam is saying that he should get himself a solar filter before November.
Well, either that or do what I do and just do a projection.
Projection sucks.
Projection is great. The best way.
I tried doing the projection thing during the great solar eclipse.
Yeah.
It was the greatest. It's
really?
better with glasses.
I suppose so. Yeah. I mean, looking through a telescope is probably the best way. But, doing a projection, that works really, really well. Works really, really well. Anyway, so there is Mercury, and it's going to be slowly sort of moving from left to right, this away. But yeah, I don't think it passes in front of the sun. It gets really, really, really close, but I don't think it quite makes it. The next time around, once it goes all the way around one more time, whoop. So once Mercury comes back around, goes all the way out, all the way back around this way and all the way in again. Next time that happens, that's going to be November something here.
Was it in a blog one time? Like, let's say if they uncovered that, it is kind of like a bit ugly and stuff.
Oh, I have no idea. I'd like to see it, but yeah, it's probably really, 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 really ugly under there.
Okay.
Really, really ugly.
So Atta, did you look at PageMaster's plans of a solar funnel?
Sun funnel. Yeah.
Yeah.
I just get the thing to screw on my scope, That's the easy way out.
Sun funnel. Never heard of a sun funnel.
Me neither.
It sounds like a lot of work to me. I'm avoiding that these days, working.
A sun funnel. Oh, okay. Yeah. It's just a projection device. Yeah.
Oh, all right. Oh, cool.
That's all it is.
Wild.
There you go.
Well, I'll be darned.
Stuff that you can get at the hardware store and works really well. Oh yeah.
Man, I'm telling you, PM, you ought to be teaching my kids. I mean, they just love you.
There you go. Well,
they already love working on building models.
Yeah.
How many grandkids and great grandkids you got?
Oh, when I say my kids, I'm referring to the kids I teach, not biological children.
Right. Gotcha. So there we go. Yeah, this is really, really cool. Really, really easy, and it's it's I guess that is sort of a good middle ground, between I mean, it sort of beats projection a little bit, I guess.
Yeah.
So that's cool. Still uses an eyepiece. Yeah. Pretty clever. Clever.
That is really cool.
Oh,
man, leave it to PM to come up with these things. I'll tell you.
There you go. But yeah, and there's a picture of a transit there too.
Hey.
Very cool.
Whoa. I'm impressed, PageMaster. I am. I'm definitely.
Yeah, he's got the goods.
Yeah.
Good. Those are the people that I like to have around, and I like to be around.
Yeah.
People who've got all the good stuff.
Look at that.
All right. Well, cool. So anyway, that's going to be happening really, really soon. I mean, over the next few days, Mercury, will go all the way across here. It'll be over here now. But yeah, in a couple more.
So Cosmic and Atta. Jim wants to know if you ever caught cosmic waves with your CCD camera. Well, I'm not sure Atta's got CCD, but I know Cosmic does.
Yes, absolutely. It's commonplace. So yeah, those are most of the time those are things that you can just sort of ignore. At least the kind of stuff I'm doing. If it comes to photography, cosmic rays, I can only imagine can be pretty nasty to have to work with. So, but in sort of what I'm doing, at least what I'm interested in doing, cosmic rays don't really affect me all that much. So yeah, I think that's a great idea. The sun funnel. Very cool.
Actually, cosmic rays affect you quite a bit. They can cause random mutations, some good, some bad.
True. Very, very true. Yep. Yeah. And I think, I guess CMOS cameras, for some reason, they aren't as affected by those things. I don't exactly know how any of that works, but I know that CCD cameras are really, really sensitive to cosmic rays. So almost every image has at least one or two cosmic rays in it, and they're just big ugly things. So yeah. Anyway, so there's that. I thought that was pretty amazing that we could actually see both of these things.
And of course, the sun is now in its sleeping.
Well, supposedly, yeah.
Yeah, you're back down to minimum conditions when it comes to solar propagation.
Okay. It's always really, really amazing to see this portion of the corona sort of evolve and change, and then you have those sort of small mass ejections there. Pretty amazing. And I think that these are set up such that this is the North Pole, this is the South Pole. So we're at a weird angle here. I don't know what that's about.
Yeah.
There's these really, really
And
dark areas.
there's your friend.
Mercury, yeah. Coming in.
Cosmic rays can throw off computer gear also. Mystery problems that disappear only for a code boot.
Oh yeah. Very, very true. So you can see a couple of background stars here. But you see all the flickering there? Those are all cosmic rays. Most of them, at least. So yeah, there's just tons and tons of cosmic rays. So yeah, pretty amazing. Pretty incredible place. Very dynamic. There's Mercury coming in. So
Atta said that Billy the Sun was the first star party she hosted at an old folks' home.
Oh, very cool. Yeah, neat.
Daytime. It was fun. I mean, everybody really loved it.
Good. Excellent. Excellent.
I mean, let's face it, the sun's the biggest thing around us.
Well, and it's pretty easy to find even in the daytime.
But in addition to the solar filter, I had a special filter I bought so that you could see detail on the sun. I can't remember the name of it. It's in my pile of equipment that I don't know how to use. This filter is one of the things that I just used because it was supposed to allow one to see detail on the sun's surface. What do they call that thing? There's a technical name for it, but
it's probably a hydrogen alpha.
Yeah, hydrogen alpha filter. That's it. I knew I recognized it when I heard it. Yeah, and it worked very well.
Yeah, well, that's just a very, very narrow band filter that is centered on a spectral line of hydrogen called alpha. And it's
Alcabel Druin said that city light pollution doesn't stop a solar observing session.
No, it
that's
doesn't.
right. That's right. Exactly.
No, it doesn't.
Exactly. Until I mean, yeah, for just like a regular, take your scope out and and look. That's absolutely true. If you're trying to make, really, really detailed measurements and stuff, the conditions of the sky do matter then. But yeah, just for looking and all that, as long as it's clear, it doesn't even.
Well, can we look at the sun in hydrogen alpha? I want to get an image on that.
Yeah, there are H alpha images of the sun, but not from any spacecraft. We have to we have to we have to go back to the ground. Trojan Alpha Solar Telescope. Let's see if we got any hanging around here.
There's a zillion of telescopes you can buy that are dedicated to viewing the sun.
Yeah, I thought that there would be something online.
But they cost about $1 zillion,
Deep Sky Through said that the Solar Data Observatory has it.
So which one?
The DSDO. And he already provided a link to it.
Yeah, I got it.
Oh.
Oh yeah, that's pretty darn good.
Oh, Gong, yeah, of course. Okay, so let's see. Well, right now there is no sun. I guess on Mauna Loa there is still. So I don't know exactly what I'm seeing here. That doesn't look exactly right. Should still be up. Mauna Loa. Let's see, is there like an archive? Yeah, there's an archive. FTP archive of H alpha data, preliminary header data. Well, I don't know what any of these are. 2019
I know there are some bits images.
There's some JPEGs. What are these? Okay, so that's just that. There's some fixed images.
Oh yeah, the sun has left the building. May that be true?
There we go. I guess these are. It's just yeah. So there it is. Just a very, very, very quiet sun.
So a solar telescope is expensive, but the PST is almost $700.
Hey, think about it. These things are just dedicated to solar viewing. You can't use them generically. That's
right.
Even for the lowest end, and that $700 bugger there, that's a lower end one.
Yeah.
Just harder.
Yeah, and Deep Sky School, and the sun is sleeping right now, so shh.
Yeah, well, it sure looks like it is because, wow, there's just not a lot going on here at all. There's some prominences here, if you can see. And there's a little thing right here and a little thing right here.
Yes, your solar flux at 67.
67. So I guess this particular image is from a telescope in India. Wow. And that was taken like 3 minutes ago. Pretty amazing.
Interesting.
Let's see if it updates. No, that's it. Oh yeah, here's the wavelength in angstroms. So 65, 62.8
Okay, so
angstroms.
PageMaster just did an archive. So again, PageMaster did an archive from the Hawaiian Solar Telescope.
Okay, cool.
Oh yeah, you need to you gotta check out PageMaster's link.
Yeah, okay. I suppose we can do that. Let's see here.
This was taken in 2015
Okay, yeah.
on the 28th of December at 1850 UTC.
Right, I see that. 28th of September, I think. According to
Yeah,
this.
that's it. Yeah.
Okay.
Yeah, so there's just a little bit more, slightly more activity.
Yeah. Yeah, the way they do the date is it's more of an international standard. I even use that when I was doing whenever I'm trying to download torrents.
Yeah. Anyway, so yeah, so there it is on sort of an active day, and that's what it looks like right now. So yeah. Hey, I don't know about you, but I sort of like a nice quiet sun, just sort of doing its thing there, right? Not too much excitement. Yeah, just how I like it. All right, well, cool. Yeah, so that's just
yeah, I like it that way too. A nice sleepy sun is okay with me.
yeah. So I don't know what the difference is here. There's an LH and a UH for each.
Go take off the actual amateur radio operator.
All right. Well, that looks really good.
Or
Excellent.
a casual shortwave listener.
Yes, sir.
Exactly. All right. Well, cool. So, all right. Well, so that was that. Let's see. Is there anything else in the chat here that I'm missing out on?
Solar shenanigans.
Solar shenanigans.
That's right. I like that. A quiet sun is a good sun.
Quiet sun
Just
is
like I always was told, if you don't have any postal mail for today, it's good news.
Oh, that's true.
And I think we just made Alta cry.
All right. Well, excellent. Let's spend a little bit more time in Aries. I was actually starting to do this, and it's like no, I really need to stop. But so we were looking at this spectroscopic binary star yesterday or the day before, Beta. Well, Gamma turns out to be a binary star too, but in this case, it's kind of visible. So the two components, it says here, are separated by 7.8 arc seconds. So
Look who decided to show up.
who's that?
Look at that big boy. I assume it's a boy.
Yeah, it's a boy.
Ah, Mr. Blackie. Got to be part of the shoe.
Yeah.
Looks pretty good to me.
Oh yeah. Probably I'll get a new collar because it's about to be worn out and stuff.
Oh, wow. You going to try to get the same kind?
Planning. I'm not sure what kind of collars they got.
Yeah, yeah, you'll find a good one for sure.
Yeah.
Oh, Blackie.
Yeah, there he goes.
There he goes. All right, well, here we go. So gamma is also a binary star, but these two we can actually see. They're pretty close to one another, but visually by eye, you put a little bit of magnification on there. You should be able to separate these pretty easily, and it's bright too. The whole system looks like a magnitude 3.9, so it's not blinding, but
Astro Live Channel says a quiet news day is always a good day.
yes, that too. But wow, these are incredibly luminous stars.
Yeah.
We're talking about the primary being 60 times the brightness of the sun, and secondary being 56. And that's just because they're so-called early type stars, or A and B. So that's just big and hot, and yep, that's what happens. Very, very luminous. Very
I'm
luminous.
not the type of person that actually doesn't watch the news all the time.
I haven't watched the news in years and years and years.
Yeah. You're just as well off. Big and hot stars. Okay.
Here you go. All right. So cool. Actually, look, it was discovered to be a binary star way back in 1664. Wow. So that's cool. Neat. So yeah, let's dive into this guy a little bit more here. Let's see what's up. Can at least maybe find a picture, if nothing else. So gamma. Oh man, how do you spell that? Arietis. 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 Like that.
More worse if you had to spell arthritis.
Much worse if I would have to do that. Yes. All right. So yeah, again, kind of interesting. This one has some pretty high proper motion too. It's moving along in the sky pretty quickly. Okay. Yeah. And here, I don't know how to read all of these things, but I think what we're seeing is like an A0 and a B9. I think this guy is actually a binary as well.
Page Master, are you saying that Captain Kirk is not even human at all?
What is that? Captain Kirk not human?
Them's fighting words, brother. Speaking of ears, you'll all notice I have my real ears on tonight.
Yeah, she had the surgery.
Real ears.
Can't believe it.
Hand clipped.
Hand clipped and everything. So here's the looks like the digital sky survey image, and at first you look at this and it's like, man, that's just totally overexposed, burned out, everything else. How can you tell if there's a binary there at all?
Okay. So Captain Kirk actually has 3. He's got a left ear, a right ear, and a final frontier.
Oh.
Boo, that is so bad.
That is just gore.
I think Page Master, deserves like a timeout or something for that one, because just put him into timeout.
No, he's good. It's also, you want to know what's also crazy? Having an eye in your ear.
Yes, we don't want that. That would, well, I don't know. Would you be able to see sound? I don't know. Anyway, you can definitely tell from these diffraction spikes that there's something interesting going on in the middle here, even though it's very overexposed. So yeah, that is a sure sign of a binary star. But here, let's see if like this, okay, that makes it even worse. I really like all these optical effects, because these stars are so overexposed that it just does it wreaks havoc on the optics. So you come up with all these really, really cool things, and these colors are nice. Here's a galaxy right next to it. Now, see, you've got the double diffraction spikes here again. You see that?
Oh, yeah.
So yeah, they're.
And what survey are we looking at?
This is Gamma Arietis.
No, what survey? What data?
Okay,
where's it coming from?
This is the Sloan Digital Sky Survey, release 9.
Okay.
So this is just multi-wavelength. I forget exactly how many wavelengths are represented here. I think I want to say 5, but I'm not quite sure. These bright stars just wreak absolute havoc on the optics. But I think they're really pretty. I mean, really, really cool colors there.
Yeah.
But yeah, I mean, you can definitely tell that there are 2 sets of diffraction spikes there. So hands down, that has got to be a binary star. But I don't think that we're going to ever see it in any of these, because it's way too bright. Yeah, see, it's just way too bright. DSS2 red. Yeah.
The regular DSS2 is pretty darn good.
So yeah, I just don't think that we're ever going to see these 2. This is definitely a case where you got to pull out your telescope and take a look, because it is definitely there. So this is a survey called 2MASS, which is pretty much infrared. This is a little weird. I don't know why there'd be 2 like that. That's a little weird looking. Oh, okay. Yeah, it's some kind of a reflection. Do you see that? It goes all the way out here. Ah, that's funny.
Like bullets.
Yeah, it's some kind of optical thing. But I guess these, I mean, yeah, some of these things are difficult to interpret, but it's some kind of internal reflection on, this initial pair, and we're actually seeing the two components, um, but they just repeat they just repeat one another. So
Hmm.
that's a little weird.
A
So
likely
that's
target for some future arachnoscope. What's an arachnoscope anyway?
what?
Tit to tat.
Oh, I don't, I have absolutely no idea what an oregoscope is, Uncle Bill.
Yeah, yeah. Clarify that for me, please.
Yeah, that's a term that I have not. I don't think I've ever heard.
I'm sure Uncle Bill knows a lot of terms you've never heard.
I can guarantee it.
That would
I,
be my guess.
I can guarantee it. Anyway, yeah.
Diffraction optics. Diffraction optics.
Thank you, Uncle Bill. Thank
Wow.
you.
Okay. Okay. Yeah. Well, I'll have to look into that. I don't think I've ever heard of that before. So cool. I'll have to look into that a little bit more. So it's kind of interesting, though. This bright star here, Gamma, is sort of surrounded by sort of a little, like a
Hmm.
cluster here of sorts. So that's kind of cool.
Uncle Bill, can you give me the Discord link for the Deep Astronomy Discord, please?
For the which, who, when?
The Deep
Oh,
Astronomy Discord.
oh, okay.
You mean Tony's
Yeah,
that deep astronomy? Oh yeah.
yeah.
I'm
If
on
you're
that
not
server.
if you're not on that yet, then
Nutty Otter.
definitely.
Hello.
Nutty Otter. Hey there, Nutty Otter. So no, this is just sort of a general, casual, fun get together each and every day where we come together and we talk astronomy, and we basically just follow our noses, and as long as we stick to astronomy and space and science and nerdy things like that, then everything's game here. So well, welcome. Glad you could come in. We're looking at the Sloan Digital Sky Survey, release number 9, of a star called Gamma Aries. And it's just a visual binary star. There's actually 2 stars involved here, and we're just taking a little bit of a tour of the constellation of Aries, and we like to look at some of the details, a few interesting things about the individual stars or the galaxies or the clusters involved there.
And thank you, Uncle Bill, for directing me to the Discord server for Deep Astronomy. Just join in.
Yep. Thank you, Uncle Bill. Thank you much. Yeah, and I think most of us are actually there. But if you're not, definitely check out Deep Astronomy. Tony has, he's great. He's absolutely great.
I sometimes watch their feeds every once in a while. I don't watch them like all of them and stuff.
Yeah. Well, good. Yeah, I like to have have choice. So you know,
Yeah.
check out his once in a while. You can come on to mine whenever you like. Yeah. So okay, well
If
let's.
it wasn't for Check Me Out, I would be turned off of Twitch.
Oh yeah. Huh.
Yeah.
All right. Well, let's see what we've got here. So here's all the different names of this guy, of this star. Just sort of the regular
And
sayings here.
oh, yes, Dave, was you looking on Check Me Out's stream? Because I didn't see you in the chat at her stream.
I was there, but I was just listening. So yeah,
Okay.
That's all I ever do is listen. I don't know what they're saying.
Yeah.
she was making some really nice sounds. So I just
Yeah.
sat back and just floated away. It was nice.
That's what you're supposed to do.
Yeah.
Hey,
Yeah.
let it float.
Just let it float away. All right. Let's see.
Something that one of my high school buddies used to say that graduated a year before me when it comes to football. Let it eat.
There you go. All right. Doesn't look like there's anything too new here. Velocity, which is probably some kind of radial velocity, probably in kilometers per second, says that this is barely moving, at least away from us or towards us, very much at all. But it's sort of moving across the sky pretty fast. So that's kind of neat. Let's see what else we have here. So a couple of references. I wonder why this guy is so interesting. Well, they're calling this a variable star, so that usually makes them interesting. Of a particular type, which I'm not too familiar with. But all right, well, let's look at the references and see what we've got here.
Okay. And watch the spells. I think what the author's trying to say, this is a great hobby and interest, and I think the autocorrect got the favor of him.
I see. Yeah, well, Eddie Otter, we think so too. So I'm just I'm pretty rabid when it comes to astronomy. So it's gone much beyond just an interest or a hobby. It's just an obsession. So yeah.
Yes, it is.
Yeah, it's just a crazy obsession. I like it. All right, let's see if there's anything else interesting here. So supposedly our target object here is mentioned in all of these, but we've actually found that sometimes isn't the case. Here's sort of an interesting one. William Herschel's agenda for his son John. Of course, the Herschels were big into astronomy and science in general back in the when was that? I think the 1700s, maybe the 1600s. I forget exactly. So speckle interferometry, they're still doing that. That's pretty amazing. They probably did speckle interferometry on this star. Well, let's take a look, huh? So they've got a 26-inch refractor there at the Naval Observatory. I don't know which one. I think that the one they're talking about is up in Flagstaff, but I could be wrong about that. Let's see what this is. Specular interferometry is a really, really interesting technique for sharpening up images. And I'm not going to get into any of the details here, but it works really, really well. The problem is that you're sort of limited in terms of how faint an object you can actually go. So you're sort of limited to brighter objects and stars and all of that. But, with a sizable scope, like a 26-inch refractor, that's a pretty big light bucket. So you could see down pretty faint. I would think that you'd probably be able to see 10th or 11th magnitude stars, because what they have to do is they have to take very, very short exposures, like at video rates, and so because of the short exposures, you just can't, there just isn't a lot of light. So if you have a faint object, you're just not going to see it. But on bright objects, I would say 10th magnitude or brighter. This kind of instrument can definitely do it, and it's a really, really cool technique. Check out specular interferometry. You should be able to Google that and find out a couple interesting things about it. All right, so this thing is taking its time here. The old potato is starting to get a little baked. So,
somebody wake me up whenever this is finally loaded.
Yeah. Make sure to wake Bobby up. Oh,
Ah, crap.
Marvel in Paradise here. We're going to try again. Empty response. That's a funny one. I haven't seen that one before.
Error empty. No, neither have I.
Empty response. Didn't send any data. That's a pretty sad looking page there too. Look at that. Oh
yeah.
Okay, look at that.
Oh, there it goes.
So okay, well, as I said, I'm not going to get into the details of specular interferometry, but let's see. I guess they don't really even publish it here anymore. But what they're doing is they are looking at binary stars. Apparently, they looked at 3,362 of them, and they've been doing this for years and years and years. As you can see, this is the this is number 17. So they've been doing this a very, very, very long time, and they have great results. So yeah, excellent. So yeah, they don't have the actual list here.
Okay, we'll see you next time, Nutty Otter.
All right. Come on back whenever you want. I'm here every single day, 2 hours UTC. So come on back. We usually go for about an hour or so. So yeah, I think we're about ready to wrap things up here. But here's some new binary stars that they
and we're about to lose Atta. She's turning into a pumpkin.
Yep. All right. Well, take care in your new form. And we'll see you later. So yeah, they are still discovering binary stars, right? So here here are some new ones. So pretty amazing. And yeah, you know, here are the magnitudes. So yeah, actually, I underestimated performance. It looks like they can see down to at least 13.6. So wow, that's pretty amazing. Pretty amazing. So making measurements like this over time with binary systems can help in determining orbits. And once you have an orbit, you can think about masses. And once you have masses, you can think about evolution and temperature and composition and all of that. So you know, doing this kind of work, this is tedious work, tedious, boring, thankless work. And they just keep doing it and doing it and doing it and doing it because it's really, really, really important. I mean, if you want to understand stellar evolution, this kind of data is fundamental because it sort of sets, you know, I mean, it is at least part of the basis for, you know, everything else. So important stuff for sure. And I guess apparently in this list, which, you know, I'm surprised that there isn't like a link or something. Let's go through this again really quick and just sort of see. I didn't see a link or anything. So maybe you just have to sort of go to, you know, the USNO and get it that way. I'm not sure. We can find out really, really quick. Should we go over there like really quick and look? So usno.navy.mil, usno.navy.mil.
That ain't happening.
Uh-oh, that ain't happening. Cannot be found. usno.navy.mil. Let's do it this way. U.S. Naval Observatory. There we go.
Yeah, here we go.
Astrometry, which is what they're doing here. They're measuring the positions of things. Optical infrared products. Yeah, so this must be it. Astrograph. Double star catalogs.
Here we go.
Start library. Oh, okay, so these are. I don't know which one is the latest one. Is it this one, the fourth catalog? Yeah, I don't know. I don't know how far I want to get into this. Let's see. I think Gamma Aries is around 1 hour or something, 153. So we can go 1 hour here. Let's see how much, how deep does the rabbit hole go? It's trying. Uh-oh. Oh,
Oh, that's a little bit rude. Go to
yeah.
advanced. Go
Yeah,
to advanced.
I know I can get into it, but I don't know. I don't like that web address. Do you see that? AD? What is AD? All right. You think we should go for it anyway? Yeah?
Let's try.
All right. Let's do it. Okay, so this is just all the okay, well cool. So yeah, this is just the list. Yeah, I'm not quite sure what each column is for. I could guess, but I'm not a good guesser. Um, let's see if there's any. Oh, here's the entire catalog. I don't think we want that though. Um, yeah, they don't give a.
Ew.
They don't talk about the format of these files anywhere. Huh. And it's really hard to read.
Yeah, time to use your zoomer.
Use the zoomer. So, yeah, the problem is I don't know. I don't exactly know how to read this. You can see that all of these. Here, let's zoom in on this a little bit.
Man, talk about
Here we
all
go.
nothing but Spanish.
So you can see here, though, that we have an RA and a deck. Right, so this is 1 hour, 0 minutes, 3.65 seconds, and then a declination of -2 degrees, 1 minute, 8.1 seconds. And it's got other names. This is probably a date of observation. These numbers here, I suspect, are what's called the position angle. So that is going to go from 0 to 360. But then, yeah, I'm not quite sure what these other ones are. Is this the separation in arc seconds? And if it is, then it's like, you know, what are these? Are these magnitudes of the components? Yeah, it gets complicated after that. So I guess these would be the magnitudes of the components, right? Like a magnitude and an error, and then a magnitude and an error, right? Because you've got binary stars, of course. But there's some notes here too. Wow. But yeah, oh wow, I'm not quite sure what these other things are. So yeah, not quite sure. But what's our guy? It's going to be around 153. So can we find? It's a big file. It's 103, 109. We've got to go all the way to 153. Let's just 46, 51. So there's 53, 53, 31, and plus 19. There it is. I'll bet you this one's it right here. Let's see. ADS 1507. Is that a? Yep. ADS 1507. So it's got a Struve number. That's what STF is. It's got an HD number, 11502. Oh, I don't see an HD here. There's an HIP number, 8832.
Yeah.
8832. Yeah. Okay. So yeah, that's it. That's it. And yeah, so I guess they have a position angle. Their latest position angle is 2.2 degrees. So one is almost due north of the other one. And then I guess this is the separation, which is 7.3 arc seconds. And at least back here in 91, these are the measurements of the two components. So, wow, so pretty close to the same brightness. Cool.
I think when you're looking at the years and those decimal points, it looks like it's like the kind of way they format it. It's got like if we could translate that, I give you when it was actually was observed.
Well, this is just a fraction of a day, or actually a fraction of a year.
No, it's actually yeah.
Yeah. So I mean, it's just a fraction of a year. So I mean, you could figure out. I think that with 3 decimal places, you'd be able to figure out what day that was, right? What day of the year it was. You wouldn't be able to figure out probably hour or minute or second, but you'd be able to figure out what day of the year it is. And that is good enough, at least, I would think. So let's see what this note is here. Gamma Aerie. According to Aitken, Robert Hooke noted this as a double in 1664. Hooke wrote, "I took notice that it consisted of 2 small stars very near together, a like instance to which I have not else met in all the heavens." So wow. So this was Robert Hooke's first time seeing at least this kind of binary star. So very cool. Neat. Okay, well, I'm noticing what time it is. I think it's about time to get on out of here for now. There is, at least in my experience, tomorrow has taken place. So yeah, I will be here again tomorrow, same time, same place, 2 hours UTC, right here. And just doing more astronomy. I love it. It's great fun, and definitely like talking about it and thinking about it as much as I possibly can. And during this hour or so, I get to share it with a whole bunch of good friends. So couldn't be better. Couldn't be better. All right, everybody, take care. Peace, cheers, and all that. Live long and prosper. Have a great time. Don't get dizzy. We're spinning around pretty fast, but it's okay. Just hang on. All right, everybody.
Yep.
Take care. Bye.